Good afternoon. I'm going to do one more lecture today. This is on section 5.1. And by what I mean by today, this is still a day which is very cold around here. It's been below zero most of the day. But anyways, this is section 5.1, so this is a new chapter, a new section, and it has to do with graphing and linear equalities in two variables. So I'm going to turn off myself, and then we'll get to it. Okay. So we're going to be doing linear equalities in two variables. The idea here is to understand, manipulate, and graph linear equalities. And from a graph, we should also be able to determine what the linear equality is. What is a linear equality? Well, we're all very comfortable with using equations. 2x plus 3y equals 5. Linear equality is very similar to that, only instead of 2x plus 3y equals 5, it would be 2x plus 3y is less than or equal to 5. Or maybe it's less than 5. Perhaps it's greater than 5. Or even greater than or equal to 5. So we previously had equality, which is just basically one side equals the other. Now we have inequalities. And the inequalities can also include equality. Basically, that's what we're saying in this section right here. Basically, that's what we're saying when we're going through here. I'm using a little bit of a different highlighting system today. We'll see how that goes. Anyways, how do we go about graphing linear equalities? Well, I'm going to take a look at the Desmos graph, which I have on the other side of the screen. And we're going to start with the equation of the line y equals x minus 1. So we're accustomed to seeing this sort of a graph. And so y equals x minus 1. So we have a line. However, when we're doing an inequality, so we're dividing the graph into two portions, an upper portion and a lower portion. So an upper left and a lower right. When we have an equality, it's a solid line. And that includes when we say it in the form of 2x or y equals x minus 2, it would be just a solid line. If it's y is less than or equal to x minus 2, it'll still be a solid line. But if it's strictly less than, so if we have y is less than x minus 2, instead of a solid line, this would be a dashed line. And here are the examples of that. So this is y is less than or equal to x minus 2. And this is y is strictly less than x minus 2. And you notice that there's a dashed line in here. Sometimes it's obvious which portions of the graph to shade, but not always. Sometimes it's actually rather difficult to determine which portions of the line to shade. I'm going to just do a couple others real quick before we talk about how we go about graphing. So we have another equation of a line, y equals minus 2x plus 5. Again, this basically splits the graph into two halves. And those two halves are y is less than or equal to minus 2x plus 5. And the other half of that graph is y is greater than minus 2x plus 5. So let's talk a little bit more. I'm going to go back to the presentation. We're no longer looking at the graph. And looking at this, there's a method to do this. How do we go about shading these lines? How do we go about figuring out where our inequality lies and where it does not lie? When we're looking at the graphs, we're just showing one side shaded or one side not shaded. But how do we know which side gets shaded? Sometimes, like I say, it's obvious. Sometimes it's not so obvious. Sometimes it can be rather difficult to make that determination. So let's figure it out. Let's see how we go about it. So we're going to start with a procedure. So we have a procedure to graph linear inequalities. We start with the equation. Ax plus by is equal to c. And I've got this square little box here. That's intentional. This is not a mistake. This is intentional. This basically says this could be a less than sign, a greater than or equal to. We don't know what's going to go in there just yet. So what do? The first thing we do is we graph the line. We graph the original line ax plus by equals c. We find any 2 points on that line in order to graph it. That's all you need to graph a line is 2 points on the line, and then we have a line. Now, paying attention to whether our inequality includes the equals or not. If it does not, if it's strictly less than or strictly greater than, it's a dashed line. If it includes the equality, then it's a solid line. Next, and so let's quickly take a look at an example of that. I'm going to, in the graph, so I'm picking a line. So we have a line. Let's say we found 2 points on the line. And this one's a little bit harder. We'd have to pick 2 points, and those 2 points that we would pick would be where it crosses the x and y axes. So in this case, it would be 3, 0, and 0, minus 6. So that's how we would do that. We find those 2 points, we draw the line. We're looking at it, and looking at our equation, it's a strictly less than. So this would be a dashed line when we would draw it. And I'm pulling that from just below where it's highlighted on the left in that graph. So this is a strictly less than. We would draw this as a dashed line. The next step is we have to figure out which side of this graph it goes on. To do that, we basically pick a test point. So we pick a test point to do that. And unless you go through the origin, picking the origin is often a very easy way to do this. So we pick that test point. In this case, it would be 0, 0. And we use that in our equation. And 6 times 0 is 0. Minus 3 times 0 is 0. So it's 0. And our equation says greater than. So is 0 greater than 18? And the answer is no. The answer is no, so that means the point, the origin, 0, 0, is not in our region. So in this case, we'll notice that our region does not include the point 0, 0. Do a couple more examples of that. So we're going to now do the line 2x minus 5y. Do I have that one? I do not, and that's okay. I don't think we need it to do this. So our example is 2x minus 5y is less than or equal to 10. Let me unset this. We're not actually dealing with anything there, so let's leave that graph empty. We pick 2 points on the line. How do I do that? First, I set x equals to 0. So I do x equals 0, and that's what we're showing here. And then we have 2 times 0 minus 5y equals 10. So 0 minus 5y. So we have y equals minus 10 over 2, which equals minus 2. That's how we're getting this first value across here. Next, we set y equal to 0. And then we have 2x is equal to 10. How do we know that? 5 times 0 is 0. 10, sorry. Which means x is equal to 5. So now we have 2 points on our line. 0 minus 2 and 5, 0. So we put those 2 points onto our line. And if we were to graph that, it would be 0 minus 2 and 5, 0. So we'd have something like this. Less than, so this is a solid line. Something along like that. Now, the next thing we ask is we need to determine which side of the inequality we shade in. That's a good question. In this case, we can use the test point 0, 0. So let's do that. So is the origin included in our graph or not? So we have 0, 2 times 0 minus 5 times 0, which is 0, is less than 10. Is this true? It is in fact true. 0 is less than 10, which means our graph includes the origin. If we scroll down, we see that this is what this graph should look like. Not too far from what I drew. Let's try another example. This time we're going to graph minus y is less than 3 halves x minus 3. So let's use some algebra. Let's simple this up a little bit. So we'll use a little bit of algebra. We'll get to the x and the y on the same side of the equation. So we have minus 3 halves x, just subtracting minus 3 halves x from both sides, minus 3 halves x minus y is equal to minus 3. There's an awful lot of minus signs in there. It'd be nice if we could get rid of that. So let's get rid of it by multiplying the whole equation by minus 1. Now, the trick with inequalities is that if you multiply the whole equation by a negative number, you have to flip the inequality. And let me explain that. So let's say we have, does everyone agree that minus 5 is less than minus 1? If we're on a number line, we have minus 5, minus 1, 0. So we can agree with this. So let's multiply this whole thing by minus 1, and that gives us 5. And if we do not change the inequality, we have 5 is less than 1. That's certainly not true. So that tells us that when we multiply by a negative, we have to invert, we have to change the inequality. So what we have is 5 is greater than 1. And everyone agrees with that. So when we're doing that in this case, we're multiplying by an inequality, so we have to change. So we have 3 halves x plus y is greater than 6. Yeah, I kind of like whole numbers. So let's multiply everything by 2, and that'll give us 3x plus 2y equals 6. Or, I'm sorry, is greater than 6. We want to graph this. Let's just first of all graph the line. We're going to start by graphing the line. 3x plus 2y is equal to 6. How do we do that? We start by setting x equal to 0. When we set x equal to 0, we have 2y equals 6, so y equals 3. That gives us this first point. So we have a point 0, 3. Now let's set y equal to 0, which gives us 3x equals 6, so x equals 2 when y equals 0. So that gives us the second point. So if we were to graph this, and this is inequality, strict inequality. So whatever we graph, so we have 0, 3, 1, 2, 3, approximately there, and 2, 0, let's say approximately there. The strict inequality, so it's a dashed line that goes through these 2 points. Okay, let's move a little bit further. Now, how do we determine what side of the inequality we use? We pick a point. Typically, if it's possible, we pick the origin. So we're going to use the origin 0, 0 as a test point for inequality. And when we do that, we have 3 times 0, which is 0, plus 2 times 0, which is 0, and the inequality says greater than 6. Is 0 plus 0 greater than 6? No, it is not. This is false. Because this is false, this point, the origin point, is not in our graph. So our inequality is on this side of the graph. And this is one way to do it. You can also shade it, whatever works for you. I'm perfectly fine with using the arrows like that. In fact, I think that works pretty well. And that's basically what we're saying in this part. Okay? It kind of covers it, but I just want to cover one more case. So let's say we have a point that goes through our origin. So let's say our inequality is 2x is greater than y, as an example. So this would change this to x minus y is greater than 0. If we pick 2 points, our 2 points would be when x is equal to 0, y is equal to 0, and when x is equal to, when y is equal, so we only have 1 point. So we know it goes through the origin. So we know we have a point, and I'm going to do this, y. So we know we have a point 0, 0. You need another point, right? Let's pick another point. Let's say x equals 1. When x equals 1, so what I'm solving here in this case is the 2x minus y equals 0 case. This is how we figure out where our line is. Sorry. So when x equals 1, y is equal to 2. This gives us 2 points on our graph. Those 2 points are 0, 0, and 1, 2. So about there. It's a strict inequality, so this would be a dashed line. Now, we want to determine which side of our inequality this is in. We cannot choose the test point 0, 0. Pick a different test point. Any different test point that's not on the line. Let's try 1, 1. That's not on the line. So let's give that a try. So then we have 2 times 1 minus 1 is greater than 0. Is 2 minus 1 is 1. Is 1 greater than 0? Yes, it is. So that tells us that the point 1, 1, which is right here, by the way, is greater than 0. In this case, it might be easier to pick 1, 0. So let's try 1, 0. So if we were to pick 1, 0, this would be 0, and then we'd still have 2 is greater than 0, and that would match out to this point right here. So we're coming on this side of the line. 2 is definitely greater than 0. That's a true statement. So this would be our graph for that equation. That is all that we have for this type for today. Thank you very much for joining me. And we'll take part in adventures on 5.2 and 3 in the next lecture.